Good morning guys, I hope we are well. In today's lesson we're going to be learning what a geometric sequence is and also how to find the nth term of a geometric sequence. Okay, let's start with the question. If this was all my working out and my solution at the end, I'm going to ask you what could the question have been? So please pause the video and give yourself a chance to think about this. So what was the question if this was my working out? Okay, so as a clue, the question I'm thinking of is all to do with compound interest, what we've done together earlier on this year. So the question, it would be something like this. You might have worded it differently, but it will be the same concept. So let's say I start with £1,000 and I earn 3% compound interest each year. How much money would I have after 6 years? So if you start with £1,000, after 6 years you get £1,194.05. Okay, but let's think, well, how would we have worked that out? What is happening at each step? Okay, so it's a 3% increase, so that's a 1.03 multiplier, isn't it? So every step I'm just timesing by 1.03 and so on. Okay, we're not going to be looking at compound interest today, so let's get rid of that stuff. I want you to think about these numbers as a sequence. Right, so in the last few lessons we've reminded ourselves what a linear sequence is. So that's just sequences that increase by the same amount each term. We looked at quadratic sequences for the last couple of lessons, so these have a consistent second difference. Today we're going to be looking at what a geometric sequence is. Again, I want you to pause the video and think about what we just discussed, and maybe you can have a guess. What do you think a geometric sequence is? So a geometric sequence is just where these numbers are multiplied by the same amount each time. So these money figures, they are actually an example of a geometric sequence, because each time I'm multiplying by the same amount. If that multiplier is consistent, that means we have a geometric sequence. Okay, so here is a sequence of numbers. I would like you to tell me, is this or is this not a geometric sequence and why? So again, pause the video if you need some more time to think. The question is this a geometric sequence and why? Okay, so this is a geometric sequence. I know that because each term is just being multiplied by 7 each time. So 21, well, I just started off with 3 and I times it by 7 once to get 21. To get that next term, well, I start with 3 and I times it by 7 to get 21, and I times it by 7 again to get 147. So I've just times it by 7 twice. To get my third term, I start with my original number and I've times it by 7 3 times, and so on. So this is a geometric sequence because I'm just timesing by 7 each time. But how would we find the nth term? So if we're thinking about a geometric sequence, how do we find the nth term? I'm going to give you a clue. We're about to find the nth term incorrectly, and we're going to use my incorrect answer to get ourselves back to the actual nth term. So here's our starting point. I'm going to tell you this is wrong, but it's not far away from the actual answer. There's a reason why I'm starting with this. So let's try 3 times by 7 to the power of n. What would the first term of this sequence be? So to find the first term of a number, I'm going to replace n with 1. So if n is 1, I would have 3 times by 7 to the power of 1. So the first term of this sequence with this nth term would be 21, because 3 times by 7 is 21. The second term would be 3 times by 7 squared, so 3 times 49, which would give me 147. To find the third term, I would do 3 times by 7 3 times to get 1029, and so on. So this isn't right, but do we see this sequence of numbers? It is actually very close to my sequence. So my sequence is 3, 21, 147, and so on. But the sequence that we've just figured out was 21, 147, and so on. Do we notice the link between our sequence here and the sequence that we were trying to get? So do we notice that the second term in our original sequence is the same as the first term in this sequence? Do we notice that the third term in this sequence, 147, is the same as the second term in this sequence? Do we see they're similar sequences but just shifted by one space? Right? So we're very close, but we just need to do a shift. Right? So this is wrong and this is wrong. That's not quite what we want yet, but let's fix it. So 3 times by 7 to the power of n, it was close, but all we need to do, we need to make a shift. I'm going to show you how you do that. Let's try 3 times by 7 to the power of n minus 1. So instead of n, I'm going to use n minus 1. That's going to sort out this shift for us. Watch what happens. So, to find the first term in this sequence, I'm going to do 3 times by 7 to the power of 0, because 1 minus 1 is 0. So that just gives me 3. If n is 2, substituting into my formula, 3 times by 7 to the power of 1 gives me 21. If n is 3, 3 times by 7 to the power of 2, because 3 minus 1 makes 2, would give me 147, and so on. So actually now, as you can see, 3, 21, 147, and so on, that matches with the sequence that we're trying to get to. So the nth term of this sequence is 3 times by 7 to the power of n minus 1. So thankfully, there's a general formula that we can use to work this out. Okay? So the nth term of a geometric sequence is given by the formula a times by r to the power of negative 1. And all that means is a is just the first term in the sequence. So the first term in our sequence was 3. Okay, so the first term, so the first part of the formula was a 3. And r is the multiplier. So that just means the amount is being times by each time. So our multiplier in that previous example was 7 because it was being times by 7 each time. So instead of r, I call it a 7. And n minus 1, I just leave that as the power. Alright, so let's bring this formula down to the bottom and we'll try 3 worked examples. So at this stage, you're welcome to try the problems yourself, so you can pause the video if you want to, or equally if you'd like to just listen to me explain the problems for you, that's also fine. So the first question, so 4, 8, 16, 32, 64. So this is probably the easiest on here. So let's ask ourselves, well, what's happening each time? And let's see if we can apply this formula to the question. So we need to start off with this a bit. So a is the first term. So the first term in this sequence is 4. So the first part of the nth term is 4. Let's look at the r bit now. R is the multiplier. So what is this being times by each time? So this one's quite easy. We're just timesing by 2 every time, aren't we? So the r bit is 2, and then it's to the power of n minus 1. So this is the nth term of that sequence. Next one. It looks quite similar, but what are these negatives all about? What's going on here? So let's use my formula and apply it to this question. So a is my first term. So my first term I can see is a 4, so this is going to start with a 4. But now r is the multiplier, but 4 times by 2 is not negative 8. I'm asking myself, 4 times by something gives me negative 8, whereas 4 times by negative 2 gives me negative 8. Negative 8 times by negative 2 gives me positive 16. So my multiplier is negative 2, so my nth term is going to look something like this, right? And I've just put that negative 2 in brackets, because if I don't, BIDMAS is going to give me something incorrect. So that if it's negative, it needs to be in brackets. Okay, and then the last question. So let's not be scared off by the algebra. Let's just take my formula step by step. So a is my first term. My first term I can still see is a 4. That has not changed. Alright, so next part. So what is my multiplier? So what's happening each time? How have I got from 4 to 8a? Well, to get from 4 to 8a, I've just multiplied by 2a, right? And that's the same to get from each term. Okay, so that means that instead of r, I need to call it 2a. And again, just note that I've left it in brackets, because otherwise BIDMAS is going to lead to some mistakes. So just leave it in brackets if you can. Alright. Okay, so if you could work your way through task 1 and task 2 on the worksheet that I've provided for you on Google Classroom, that would be great. All of your solutions are on the worksheet, so please use those to help you. And as always, if you need any help, please just get in contact with me, because I'll be working all day and I'm at my laptop, so I'll be here to check your emails and questions and things like that. Okay, thank you very much.